So here we're going to discuss parabolas. There's two ways to do this. One is a simpler way that just deals with the quadratic equation and looking at the parabola in vertex form. Another way is to talk about it through conic sections. And in this case, we're going to look at it in the more brief way of doing it, where we just look at it in terms of quadratic equations, similar to the steps we use to solve a quadratic equation. So we'll look at two parabolas, but focus mainly on one. There's the y equals ax squared plus bx plus c. If you notice that the x variable is the one being squared, that's kind of the deciding trait that would give you a parabola shape. A parabola shape is this U-shaped curve here. If you notice, this U-shaped curve is going vertically, and that equation would give you that shape of a parabola. And then we have the x equals a y squared plus by plus c. If you notice here, the y is the one that is being squared. And that would give you this U-shape turned sideways here, going horizontally. We'll primarily focus on this first one, because that's the one you see right now most often. But noticing, which variable you squared changes the direction of the parabola, either vertically or horizontally. So if you notice a vertical parabola, in this case, this vertical parabola that we're seeing right here, there's kind of two defining things here. One is the vertex, which you see right here. It's that bottom point of this parabola. You could also see a parabola shaped this way, in which case the vertex is the top point, but it's really the defining point of the U shape. And then you have this line of symmetry. The line of symmetry essentially cuts the parabola straight in half. It goes straight through that vertex. So if you know where the vertex is, you can then also figure out where the line of symmetry is. One way to find the vertex for a parabola in this y equals ax squared plus bx plus c is to put it in what we call vertex form. We can get to vertex form through a couple of means. One is through completing the square, or two is just through a simple formula for finding the vertex. In this vertex form, this h and k will give you the values of the vertex, h being the x value and k being the y value for the vertex. And that goes for whether it's a vertical parabola turned upwards or upside down parabola like this. Either way, vertex form will give you that. So if we look at this, we could find hk simply through a formula. Okay? Looking at this a, b, and c from the standard form, a being the coefficient in front of the x squared, b being the coefficient in front of the x itself, and c being the constant, we could use those values to find the vertex. So negative b over 2a would give me the h value, and this negative d over 4a, where d is b squared minus 4ac, would give me the y value. Okay, so that's one way to do it. And then we could use that here in this vertex form. This a that's up here is the same a that's down there. So that's pretty simple. Again, one way to do it. Negative b over 2a for the x, and then in this case, negative d over 4a, where d is b squared minus 4ac. If a lot of this looks familiar from the quadratic formula, there's no coincidence, because basically all of this comes from completing the square. So if you think about our standard form here, if we were to factor out that a and start trying to do completing the square, because remember, for completing the square, we need to get the a to remove there and only have the x squared. If we factor out the a, we would have x squared over b over ax, because you don't have an a here, but if you factor an a out, you would have to multiply back in to get where we started. So in this case, it would be b over a. Okay. Then if we complete the square, we have to add this term here, which is what? Half of this, right? So divide this by 2, b over 2a squared, add it to this piece so that we can factor this out. And if we did, the factor we would get would be this. Okay? But remember, if you just add something in, you got to also take it out. So this is a times this. Okay? And so we have to subtract that off of this whole thing. So negative a times b over 2a squared. Well, do a little computation here. If you were to square this, you would have b squared over 4a squared multiplied by a. One of these a's will cancel. So now you only have 4a, and then combine it with the c. What do you get? Well, this is basically what you get here. So you get this a times x plus b over 2a squared minus b squared minus 4ac all over 4a. Remember, this is your h, and this is your k, and there's your vertex, because this is this a times x minus h squared plus k vertex form. So you see where those values that we were just talking about come from. In the long run, if this was maybe a little bit difficult for you to follow, you just really need to know what the values are for the vertex h and k. So if we had a question like this where we had to find the vertex form of this quadratic so that we could then graph it by using that vertex, what we could do is either say, well, a equals 1, b equals -4, and c equals 3. C equals 3, okay? And we could just use the formula, or we could complete the square. I'll complete the square, and then we'll use the formula, and you'll see how you get the same thing. So in this case, we don't have a, since a is 1, we don't have to worry about factoring a out. So I'm going to say, okay, we have x squared minus 4x. We have the plus 3 here. We're going to complete the square with these terms. So we take this one and divide it by 2, which would give me -2. So if we add -2 squared, that'll allow us to complete the square. But if we add -2 squared, we also have to subtract -2 squared, so it evens out. Then we have x minus 2 squared from this. That's our completing square process. Here we have 3 minus 4, which is -1. And now you have vertex form. In this case, here's your h, here's your k. So h is 2 and k is -1. So my vertex is 2, -1. If I use the -b over 2a and -b squared minus 4ac all over 2a, all over 4a, okay, as my formula for my vertex, you would see we get the same thing. So think about it. B is -4. 2a is 2 times 1. So if we use that for this piece here, we would have -4, so it would be +4, all over 2 times 1. Well, 4 over 2 is 2. And that's exactly what we got. And the same thing would happen here with the h. Now, here's the thing. If you know where the vertex is, graphing a parabola is very easy. So 2, -1. There's your vertex. There you go. Now, I guess there's one other thing we need to add in there is, how do we know that it's going upwards or going downwards? Like, how do we know which way to, if once you know where the vertex is, how do you know that that vertex is the bottom point or the top point? Well, it really has to do with a. If a is positive, you would have an upward shaped parabola. If a is negative, you would have a downward shaped parabola. So it's all about what sign you have for a. Once you have those two pieces, you basically have everything you want. And remember, the axis of symmetry goes straight through that vertex. So the axis of symmetry would be the vertical line through, in this case, an x value of 2. So it would be x equals 2. Here's another one. Find the vertex form for this quadratic function. Now in this case, a is positive, so we know we're going to have an upward parabola. But a also isn't 1 anymore. So what we would have to do is we'd have to factor out the 2. Then we'd have to complete the square. So if we factor out the 2, we have x squared plus 3x. And we're only factoring the 2 out of these terms. Remember, you don't care about the constant when it comes to completing square. Just leave it off to the side. Okay? So we factored 2 out of these pieces. This is what we'd have to divide by 2. and square it. So if we divide it by 2 and square it, that'll allow us to complete the square here. Now, we can't just add that in. We have to also subtract it. Well, what are we going to subtract? 2 times this. So 2 times 3/2 squared is going to have to be subtracted off. All right, so what do we get? Well, we have 2 times, this thing would be x plus 3/2 squared. Okay, that's this piece. Then here, what do we get? Well, we have -1 minus 2 times 9/4. Well, cancel this, it's really 9/2. So -1 minus 9/2. Well, -1 is 2/2. So -2/2 minus 9/2 is -11/2. So you have your h and your k. Remember, this has to be in the form of a times x minus h squared plus k. So if that's the case, then h is going to be -3/2. Opposite sign in here, okay? And k is this value, so k is -11/2. So your vertex would be -3/2, -11/2. And so since a is positive, we have an upward parabola. So if we were to graph this, it'd be pretty easy to do. -3/2 would be, right about there, because here would be -2, here would be negative, let's say that's -1, so -3/2 would be there. And then -11/2, well, what do you have? -10/2 would be 5, so this will be a bit farther than 5, so 1, 2, 3, 4, 5, so let's say here. So there's my vertex, there's my parabola, there's my axis of symmetry, and we have our parabola. Again, this is kind of more of a brief overview of parabolas. We can get into more depth if we went in through something called conic sections. We talk about focus and directrix. It's not necessary for us right now. So really, this is just applying the things we learned with the quadratic formula and completing the square to graphing these quadratic equations.